So in this class, we will discuss one of the methods of statistics, which is called as method of least squares. So method of least squares means, suppose you are given a set of data x and y. The data set is given. For example, this can be 1, 3, 5, 7, something like this, and this you can have some values 2, 8, 10, 15 like this. So two sets of data are given, x and y. Now we have to fit an equation of this type, y is equal to f of x. So they will give set of data, two sets of data x and y, random sets, discrete data. We have to find an equation. So this equation we have to fit in such a way that this data set is acceptable to this equation. Almost this equation satisfies these data sets. If you put x value, you have to get that y value according to this equation. And this equation can be linear, it can be quadratic, or it can be exponential. So three types are there. So these three types we have to cover. So y is equal to this f of x can be either linear or quadratic or exponential. So the concept of least square says, suppose if you have y as or yi as the observed values in any phenomena, capital Yi are the estimated values are expected values. Then the difference between these two, that is y capital Yi minus small yi, and square of it. Actually, this is called as this difference is called as residue. The difference is called as residue, or it is also called as error. So residue or residuals or estimate errors. Residuals or estimate errors. The difference is called this. Now, if you take the square of this, yi minus yi whole square, so this is called as square of residuals. So each this y corresponds to yi, x corresponds to xi. You will be having another set of data, capital yi. So the difference between capital Y and small yi is called as the residual or the estimate error. And we have to take square of that, then we have to sum this. So summation of capital yi minus small yi square. Summation of all these values. So this is called as sum of squares of residues. Now we have to fit this equation in such a way that this should be minimum. When the difference between observed value and expected value is minimum, then error is minimum. That is the minimum. So here, this we have to find the equation y is equal to f of x such that sigma yi minus small yi square is minimum or it is least. This is very important in statistics. So whenever you are fitting a model, whether it's a statistical model or any other model, so the condition, one of the conditions to have best model is the error should be minimum. The error should be minimum means here we are going to take the sum of the squares of the residuals as minimum. So this is the basic principle behind this method. That is why this method is called as method of least squares. So that means this square, sum of the squares should be least or minimum. So based on this principle, we can always develop an equation of these three types: linear, quadratic, or exponential. So let us take first linear equation. How to fit a linear equation? So for a given set of data x and y, how to find linear equation? So linear equation we can take in this form: y is equal to a plus bx. So we can see that this is the equation of a straight line. So for a given set of data of x and y, we can always plot. We can always get a discrete line like this. This is x, this is y, this is the origin. If you plot these values, whatever is given, on a graph, so something like this, and if you join the points, discrete line like this, then this line may cut or intersect the y-axis at some point here. So this is your intercept. So this intercept is A, and B is the slope. So you have studied all these in earlier mathematics. So if this is the equation, then if this is the straight line, the equation of this line is y is equal to a plus bx. So in mathematics, you have learned in earlier classes that y is equal to mx plus c. Where m is the slope and c is the y-intercept. Here, this a, the same equation can be written like this. This a is called as the y-intercept, where that line cuts the y-axis, and b is the slope of this. So if this is theta, then tan theta is. So this is the physical interpretation or theoretical interpretation of this equation. Now I will take up a problem. So to get the equation of this type, we have one thing called normal equations. So let us not worry about the derivation of these normal equations. To get the coefficients a and b, we need two equations to find coefficients a and b. So we need two equations because there are two unknowns there. Once you get the values of a and b, equation can be obtained. So the normal equations are na plus b sigma x is equal to sigma y. This is first equation. N into a plus b into sigma x is equal to sigma y. So this is first equation. The second equation is a sigma x plus b sigma x square. A into sigma x plus b into sigma x square is equal to sigma xy. So these two are called as normal equations, which we can use to get the coefficients a and b. So this is first equation. This is second equation. So for a given set of data, x and y will be known. You can always find out sigma x, sum of all the x values. Sigma y, sum of all the y values. Sigma xy is the sum of the product of x and y values. Sigma x square, all this can be found out. This n is number of data points. How many data points are given? Maybe 5 or 10. How many data points are given? That is the number of data points. Suppose if they give 5 values here, n is equal to 5. So like that. So once you know these things, here only a and b are only the unknowns. So two equations you are going to get, simultaneous equations. So if you solve these two equations, you can get the values of a and b. So we have to solve to get a and b. So once you get a and b values, this becomes the equation. N is equal to a plus b. That's all. So we have to remember these two normal equations to fit a straight line. Now let us take a numerical example. So the question will be given like this. Problem will be given like this. Fit and obtain an equation of the form y is equal to a plus bx, They can ask like this also: obtain a linear equation. Obtain a linear equation to fit the following data. To fit the following data. So they will give the values of x and y. So in this problem, he has given the values like this in the form of a table. So here he has given x value of 1, 3, 4, 6, 8, 9, 11, 14. So there are 8 readings, 8 data set points. Corresponding y values are 1, 2, 4, 4, 5, 7, 8, 9. So this is the data set. So this much they will give. So we have to find out a suitable equation of this form. Y is equal to ax plus b. Using these normal equations. Now from the given set of data, we require these things. We require sigma x, we require sigma y, we require sigma x square, we require sigma x square. These 4 things we require. Okay. Now, for that given set of data, let us find out those things. Sigma x. What is sigma x? We can just add the values. For the given set of data, what is sigma x? 1 plus 3 plus 4 plus 6. Like that, you have to add. So for the given data, sigma x is equal to 1 plus 3 plus 4 plus 6 plus 8 plus 9 plus 11 plus 14. So 8 to 14, 22, 31, 42, 56. Sigma x becomes 56. Sigma y, we add these things. 1 plus 2, 3, 3, 7, 7 plus 4, 15, 11, 11 plus 5, 16, 23, 23, 31, 40. So sigma y is 40. Then I need sigma x square. You see, I need sigma x square. Sigma x square is sum of all those 1 square plus 3 square plus 4 square plus 6 square plus 8 square plus 9 square plus 11 square plus 14 square. This is sigma x square. Similarly, I need sigma xy. Sigma xy. So product of x and y we have to take and then we have to add. So 1 into 1 is 1 plus 3 into 2 is 6 plus 4 into 4 is 16 plus 6 into 4 is 24 plus 8 into 5 is 40 plus 9 into 7 is 63 plus 11 into 8 is 88 plus 14 into 9 126. So let us find out these 4 sums. So sigma x square is, what is the value of sigma x square? 524. And just check. 524. You can just check it there. Then sigma xy is 364. 364. Sigma x is 56, sigma y is 40. And here the number of data sets 8. 1, 2, 3, 4, 5, 6, 7, 8. So n is equal to 8. Number of data sets n is equal to 8. 8 sets of set of data. So once you get these values, now these normal equations are used. So substituting in the normal equations. So the first equation I will take n into a plus b into sigma x is equal to sigma y. The second equation is a into sigma x plus b into sigma x square is equal to sigma x square. So you have to remember these two equations. So n into a, n is 8 here, 8a. So a and b are unknowns now. We are finding a and b. Plus sigma x into b, sigma x is 56. So 56b is equal to sigma y is 40. So this is first equation. Second equation is a is unknown here into sigma x. Sigma x is 56. So 56a plus b into sigma x square. Sigma x square is 524. 524b is equal to sigma xy. Sigma xy is 364. Now these two are the equations. So we can have to solve these two equations to get the values of a and b. So if you solve these two simultaneous equations, that you can do using calculator. So using calculator only you can solve this. I hope you know how to use calculator. You go to that mode. In that mode, you have to go to equation. That is 1. Then unknowns, two unknowns. There are two unknowns, a and b are the unknowns. It will ask for the coefficients a1, b1, c1. First equation coefficients. a1 is 8a. This is a1, this is b1, this is c1. a2, b2, c2. That's all. So a1 is 8 is equal to b1 is 56 is equal to c1 is 40. So this is one equation. Then second equation, a2 is asking 56. Then b2 is 524. Then c2 is 364. So once you give these values, directly it will give x and y. X is your a here. So if you by solving these two equations, x is a here, y is b. X is equal to 0.44545. 3 digits I am taking is equal to, then y is equal to 0.636. So these are the values of a and b we are going to get, 0.545 and 0.636. So once you get these a and b values, you can write in this form. So that is the equation. So therefore, best fit line equation is y is equal to a plus bx, that is y is equal to 0.545 plus 0.636 x. So this is how, this is the equation. So this is the answer, best fit line. So to find the best fit line for a given set of data, you should be knowing the normal equations. There will be two normal equations for a linear equation. So these two normal equations, we need these sums. Then we need to require 4 sums: sigma x, sigma y, sigma x plus, sigma xy. So for the given set of data, you can find all the 4 sums, and n is the number of data that we can write. Then you formulate the normal equations. So those two equations you can solve using calculator itself, and finally you get those a and b values. So this is the equation. So y is equal to a plus bx. So sometimes if he gives y is equal to ax plus b, then you should be careful. So suppose I will write here, if they ask you to find the equation in the form ax plus b. Here I have taken, if it doesn't give anything, you can take y is equal to a plus bx. What I have done now. Suppose if we ask in this form, if the equation is y is equal to ax plus b, then normal equations will be slightly different. Normal equations, you have to interchange a and b. So normal equation for a plus bx, for a plus bx is this. Okay. For ax plus b, then you have to interchange A and B here. That's all. Nothing else. Huh? So interchange. A and B. If it doesn't give any equation, then you can fit this. If he asks y is equal to ax plus b, then you have to interchange a and b here. That means this equation becomes now n into b plus a into sigma x is equal to sigma y. Other equation is b into sigma x plus a into sigma x square is equal to sigma x. Okay, that's all. The remaining steps are same. So a and b should be interchanged if they ask in the form ax plus b. So what happens in that case? You are going to get a value as what is the a value you are going to get?
0.5.
A value you are going to get 0.636. B value you are going to get 0.54. That's all. Same equation we are going to use. So if you are using this, A and B values are interchangeable. So A value becomes B value. That is 0.636. 0.636, and B value becomes A value, which is 0.54. That's all. So anyway, I am going to get the same equation. Y is equal to ax plus b means it is same. 0.636x plus 0.54. Okay? You are getting the same. You are getting the same. Correct. Other equation bars. Interchange first. So first x, then constant term. Here in this equation, first x term, then constant term. In this equation, first constant term, then x term. But anyway, the values of a and b remain same. So this is how we can fit a linear equation for a given set of data of x and y. Okay, this is by the method of least squares. So any data they may give, negative values they may give, positive values they may give. You have to remember the normal equations, and we have to obtain the normal equations, these two equations by writing down the sums. Then solve the normal equations, get the constants a and b. You substitute those values of a and b in the equation, you are going to get the best result.